Okay, so for the next couple chapters, we are going to be looking at geometry. We're going to be switching out from regular math, multiplication, division, fractions, decimals, to working with geometry, so lines and rays and angles and shapes. So before we get started tonight, I got a little video clip for you. Let's go watch that.
We speak student.
Lines, segments, and rays. Oh my, a la Shmo. This is Astrid. She's first in line at a midnight video game release. It's currently 9 p.m. If only she could apply this kind of ambition to her schoolwork. With such a long time to wait, Astrid is bored out of her mind and wonders if there's a way she can make her situation more interesting. For once in her life, she decides to relate her circumstances to a mathematical concept. Astrid is a stationary point at one end of the line, so let's call her point A. Her best friend, Basil, just got in line at the other end. He can be point B. The line is getting longer all the time as additional devotees arrive. More and more people keep appearing behind Basil because the game is so darn popular. In fact, the line is growing infinitely. If Astrid never moved from the front of the line, we would say she's standing in a ray. It has one endpoint, A, and extends infinitely in the direction of point B. So we would call it ray AB. Now imagine someone cuts in front of Astrid while she's distracted. And while she was busy arguing with that person, another person cut in front of them, and so on. If the back of the line kept growing indefinitely and the front of the line was also growing indefinitely as more and more people cut, we would call this line AB. That's right, a true line in mathematical terms extends infinitely in both directions. So in reality, Astrid and Basil are currently waiting in a line segment, specifically a line segment with endpoints A, B. So it would be technically inaccurate to say they're waiting in line. Well, that killed about 2 minutes. Only another 2 hours and 58 minutes to go until she can get her hands on Math Blaster 4, The Revenge. Astrid prefers blowing up math problems to solving them.
Alright, that was a cute little video. Alright, so as they were saying, a line, definition of a line is a straight continuous set of points that are never ending. Okay, that's why you have these little arrows at the end. Okay, they continue to go to the left, they continue to go to the right. And how you would see that written in geometry is just like this. It'd be AB with a with two lines or two arrows going in each way. All right, a line segment. Definition of a line segment is a part of a line that has two endpoints. You have a point here, R, you have a point here, F, and it will be written like this, okay, with the points on each end of a line segment. That means it doesn't extend past the points. That's the piece of line that we're dealing with. All right, array. Array is a little bit of both. The definition of array is a part of a line that starts with one endpoint and goes on continuously in the other direction. Okay, so we start here with R, and it continues to go way past S. That's why you have the arrow. Okay, and it is written like this: R, S, with a point and an arrow going the right way. So the line can't continue this way. It's only going to go to the right. All right, a point is a location in space. It's a point. So I can put a point here, I can put a point here, I can put a point here, I can put a point here. Okay, and it's the symbol is whatever you name the point, which in this case is C with a little dot above it. Okay, so in the next couple of days, we'll be talking about parallel and perpendicular. This was part of the Smartboard lesson, and I liked it, so I'm just going to have you go ahead and write these definitions down, and we'll revisit them later on in the week. Parallel is defined as lines that never intersect. Okay, so the lines, again, have the arrows at the end, and they never cross each other. They can go on as long as they want in the direction of left or right, but they never cross. All right, perpendicular lines, they cross, but they cross and form right angles, okay, which are 90-degree angles. We'll be talking about angles here this week as well. Okay, so Perpendicular lines are lines that go up and down and across, and they make they make a right angle right here. Okay. All right, and let's see, intersecting lines that cross at any point. Okay, it could be crossing here, it could be crossing there. They don't have to make right angles. Okay, angles, that's tomorrow, I believe, or the next day. So acute angles are angles less than 90 degrees. Obtuse angles are more than 90 degrees. Straight angles are 180 degrees. That'd be straight. And then right angles are 90 degrees. You guys have seen right angles and acute and obtuse before in lower grades. All right, so before we start your homework, I have another video for you to watch because I'm the coolest teacher ever.
Hi there. Today on Math Antics, we're starting a new subject where we're going to learn the basics of a special kind of math called geometry. Geometry is the study of things like lines, shapes, angles, distances, and things like that. In this video, we're going to focus on three of the most basic elements or parts of geometry. They are points, lines, and planes.
Pay attention to the planes.
All right, we're going to start with points because they're about the simplest thing you can imagine in geometry. What's a point? Well, let me draw some for you. So these are points. They're just little tiny dots in space, but they do a really important job in geometry. They help us describe specific locations in space, like the end of a line, or the corner of a square, or the center of a circle. But they won't really help that much unless we name them, because if I say, hey, look at that point over there, it's kind of hard to tell which one I'm talking about. I mean, they all look the same. So what name should we give these points? Well, let's see. How about Archimedes and Beauregard? That'd be good. Maybe Charlemagne? How about Daphne and Einstein? Let's see. Fred and Guinevere, Hiawatha, and Icarus. Perfect. You know, on second thought, those names are kind of long and complicated. Why don't we just use the first letters of each name instead? There. Now if I say, look at point A, or look at point B, you know exactly what I'm talking about. In fact, let's do that. Let's just talk about point A and point B for a minute. If you start at point A and go to point B taking the shortest distance possible, you would have gone in a straight line. A line is the next most basic element of geometry. We name a line by the points that it goes through. For example, we would call this line AB because its endpoints, where it starts and stops, are points A and B. But technically, this isn't really a line. It's a line segment. What's the difference, you ask? That's a good question. A line segment has a beginning and an end. It starts at one point in space and it ends at another. A line, on the other hand, just keeps on going in either direction forever, just like the number line keeps on going forever. Well, at least we imagine that it goes on forever. We can't actually draw a line that goes on forever, so here's what we do instead. To draw a line instead of a line segment, you just go past the endpoints a little bit, and you put an arrow on both ends of the line to show that it keeps on going. So this is line segment AB, and this is line CD. Now there's one more special type of line that we need to talk about, and it's basically a combination of a line segment and a line. We call it a ray. Rays have beginning points, but no ending points. They just keep on going forever, but only in one direction. So we only put an arrow on the end that keeps going. There. We call this one ray EF. In geometry, each of these three types of lines has a shorthand way of writing it. Instead of writing line segment AB, you can just write AB with a line over the top. And instead of writing line CD, you can write CD with a double arrow line over them, like this. And finally, instead of writing ray EF, you can just write EF with a single arrow line over them, like so. Okay, so now you know about points, and you know that you can form a line between any 2 points. The next thing we're going to learn about is planes. No, not the kind of planes that you fly in. Now, to help you understand how planes and geometry work, let's go back and look at all those points that we had at the beginning of the video. It looks like all the points are the same depth on your computer screen, right? And if they were, we'd say that they're all in the same plane. And that's because your computer screen is a plane. It's a flat surface like a window or a sheet of paper or a tabletop. A plane, or flat surface, is what we call a two-dimensional object because there's two dimensions that you can move in. You can go up and down, or you can go left and right. A line, on the other hand, is a one-dimensional object. If you're on a line, like line AB, there's only one dimension that you can travel in. Sure, you can go forwards or backwards along that line, but it still has only one dimension. You can't get to point C without going off of line AB. But if you're on a plane, a two-dimensional object, then you can get to point C, because point C is on the same plane as points A and B. All three of them are on that flat two-dimensional surface, which is your computer screen. Cool. So that means that if I want to get to point D, I can do that too, because it's on the same plane as A, B, and C, right? All right. I have a confession to make. I tricked you. Point D really isn't in the same plane as the computer screen. It just looks like it from the position you're viewing it from. Watch what happens if I start rotating the screen space a little bit. Aha! Now you can see that the points are actually scattered all over the place in space. Point D is actually in front of the plane that A, B, and C were in, along with some of the other points. And the rest of the points are actually behind the plane that A, B, and C are in. What we have here is a three-dimensional space, or 3D space for short. In a three-dimensional space, there's three dimensions you can move in: left to right, up and down, and in and out. If we're on the plane that contains points A, B, and C, we can't get to point D unless we leave that plane by traveling in that third dimension. A three-dimensional space like this is often called a volume, but we'll talk all about 3D volumes in another video. For now, let's get back to talking about planes. Earlier in the video, we learned that you can make a line by connecting any 2 points, right? Well, in order to make a plane, it turns out that you need to have 3 points. Like our 3 points A, B, and C. If you just connect A and B, you get a line. But if you connect A, B, and C, you get a triangle. Now you're probably thinking, wait, I thought we were supposed to get a plane, not a triangle. Well, because it is a flat surface, a triangle is a lot like a plane, but it has 3 edges. It stops and doesn't keep on going forever. When we were talking about lines, do you remember how a line segment had endpoints, but a true line kept on going forever? Well, it's kind of the same way with triangles and planes. You could think of a triangle as a smaller part or a segment of a plane, but the plane itself keeps on going forever. So 3 points is all it takes to define a plane. And in the space we've been looking at, we already have plane ABC. So let's try making some other planes with the rest of the points. We can choose any 3 points that we want to. Let's join D, E, and F. And we can see the triangle they form. And if we extend that flat triangle, we can see the plane that it defines. Let's try one more so the rest of the points don't feel left out. Let's join G, H, and I. There. Now they form this triangle, a flat surface that forms this plane if we extend it in every direction. So now you know about planes, lines, and points, 3 basic elements of geometry. There's a lot more geometry ahead in upcoming videos, so stay tuned. And you can check out the exercises for this section. They're pretty easy and they'll help you remember what you've learned. Thanks for watching, and I'll see you next time. Learn more at mathantics.com.
Alright, pretty cool video. I know that the planes one was a little bit difficult to understand. We won't go into third dimensions or 3D here in this class, so don't worry too much about that, but at least if anybody ever asks you, you kind of know a little bit about it. Alright, so name the geometric term that best represents the object. Okay, so the top of a desk extends in all directions. It's a flat surface, so that is a plane. Alright, let's see. Chalk tray, I'll let you guess that one. It's like the tray that Miss Fernley sets her expo markers on and the erasers. Okay. Point from Earth into space, so a starting point like where you're sitting right now, all the way into space. We don't know where space ends, so that gives you kind of a hint. And north, northeast on a compass, so imagine you have a compass, starts here in the middle. Miss Fernley needs to calibrate her frontboard, and it goes that way. Alright, I'm going to calibrate my smartboard real fast. Okay, well, that's not going to work, so let's just try to finish this out. Name an everyday object that represents the items. I'll let you try doing that. Draw and label an example of each dot on the paper. Plain, I will do that for you. Okay, so plain would be like, oh, doesn't want to write now. A, B, C. Okay. So A, B, C. So that would be plain. That'd be number 9. Like line segment, you can do. Ray, I'm sure you can do. Point, you can do. Problem solving. Use the data. What geometric term describes the place where the ceiling and a wall meets? Okay, so the ceiling and a wall right here. What is that? What features in the hallway show planes? So if you're looking at the hallway, what shows planes? And what geometric term best describes the arrow? I'll give you one on the hallway. The floor. Okay, the floor is a plane. Describes the arrow. Okay, what geometric term best describes the black dot on the window? Okay, you guys can handle all of that. Your WSQ is to finish the practice book page and draw me an example of a line, point, ray, and a plane. And we'll see you in the morning.